Okay, thank you everyone for joining us today. I'm Danny with B9 Creations, and I will be joined by Eric, whom you see here, our product manager, as well as Cody, who's our sales engineer. Both will be helping facilitate this webinar and our brand new material, as well as answering questions at the end. And if you have questions at any time, please feel free to drop them in the chat, and we will address them when we reach the end of the webinar. As a global provider of digital manufacturing technology, B9 Creations has become the industry leader in production, speed, and value. You can see some of the high-value industries we serve here, ranging from medical to manufacturing, aerospace, and beyond. And our track record of exceeding these customer requirements has actually helped us be named to both the Deloitte Technology Fast 500 list in 2019, as well as the Inc. 5000 fastest growing companies in the USA. Here you can see some of the blue chip customers that we serve across key industries: healthcare, aerospace, industrial sectors, research, jewelry, and our new B9X division, where we're actually developing custom platforms from hardware, software, materials, and beyond to meet customers' needs. We serve these customers in nearly 70 countries across the globe, alongside our global dealer network and strategic partners. So with that, I want to get to the real meat of the webinar, our brand new material, Robust ABS PC. Eric, I'd love to kick it over to you to tell us a little bit more about the material properties and what differentiates this from other resins on the market.
Yeah, thanks, Danny, and thanks for having me. I guess to start off with, this is our new Robust ABS PC resin. It's a liquid photopolymer for use in all of our core series printing platforms. The intent of the product is to mimic the properties of ABS PC blend, which is a popular thermoplastic for injection molding. It's something that a lot of engineers are probably familiar with working with, and we kind of wanted to connect those people who are designing these parts with something that they're more used to, so that they can kind of place where they would use this product in their additive journey, I guess. Some key points I would note about the product: it's got a high flexural modulus. So it's a stiffer material. It's on the stiffer end of our product portfolio. I'll kind of talk about that in terms of how it compares with other materials in the portfolio kind of later in the presentation. It's also a high impact resistance material. So if you've got parts that need to withstand a little bit of force and actually need to be used, not just look nice, this material will be good for that as well. On the plus side, it also does look very nice. So it's got this really great matte surface finish that makes the parts look almost injection molded. I mean, they have this really nice uniform matte finish across them. Yeah, is there anything else you wanted me to touch on that slide, Danny?
No, I think it's perfect. One of the things that's so nice about the form of this material is not just that smooth satin finish, but it's actually very high precision. So you can get pretty incredible detail paired with that rigidity and strength that you need for functional prototypes through end-use parts. And that's been something our beta customers have actually given us feedback on, is it looks really good. It looks as good as it functions.
Absolutely.
One of the things I think would be helpful for people is if you could go through some of the most common applications for this material, kind of as people move from this prototyping all the way through bridge to scaled production. Could you talk a little bit more about that?
Yeah, for sure. So there's the kind of places that additive always kind of shoehorns into, right? So conceptual models, if you just need to convey a thought or an idea, or if you need a part that's just a physical representation of something that you're trying to get produced or get brought into reality. Additive is always great for that. This material is no different. If you want to take it the next step into that prototype actually needs to function in an assembly with other components, this product is great for that too, because it's got the end material properties that are going to lend itself to actually being a little more durable and um, lasting in, say, field testing. Or we have people that are actually going all the way through to production parts in this material, which is the last bullet point you see on this slide. So that high impact resistance, the good rigidity of this material lend themselves well to that. It's going to mimic, like I said before, it's going to mimic those thermoplastic properties that engineers are kind of used to designing around already. So it's going to be very good for that. Another good thing as a manufacturing tool, there are multiple benefits to having or taking your manufacturing tools additive. You know, some of them being not needing to store spare tools, you know, having that digital copy of your tool where you can reproduce the tool in a matter of hours to the exact same tolerances that you were operating with before, should anything break. So you don't have that overhead of storage. And as well, you know, while it's sitting on the shelf, what could happen to it? You know, in the digital realm, that file is going to stay intact until you need it. So that's a fantastic thing. The strengths again of this material are its impact resistance. So if you need anything like soft jaws or work holding or clamping or you know, grippers, anything, bump stops, anything along those lines that are frequently used out in the factory, this material would be fantastic for that. We also do have a couple customers that are getting into an injection molding application for this material due to its high heat resistance. And I think that's something that we'll probably talk about a little later on as well. But we're also seeing very good results in that realm as well.
Yeah, and before we switch to kind of this 3D printing injection and metal molds, which is a very exciting application, something that's been wonderful about it having a little bit higher heat resistance is we have customers, beta testers that use this near motors. And really, if you know other 3D printing resins or even our own suite, sometimes that got a little soft when you got some of those functional parts near that heat. So not just an injection molding, but really in environments where you don't just need impact resistance, you need higher heat resistance as well.
Yeah, absolutely. If you think of automotive interiors, or, you know, the Additive is notorious for, hey, these parts look great, they're awesome, but if you leave them in your car dashboard, they're not going to work anymore. This material is not that way. You can take it outside, you can leave it in a elevated temperature environment for sustained periods of time, and it's going to still perform.
So with that, I'd love to get to this application. Eric, could you give maybe a little background on how we discovered that this was a good fit, and then talk through the differences, benefits of switching from traditional mold making to leveraging 3D printing for this?
Yeah, for sure. We had a couple customers reach out to us directly because they had old injection molding machines in their facilities that were at one point used for R&D, but they were actually abandoned because of the cost and the time associated with making them work. So we've actually seen a pretty interesting phenomenon, I guess, through our testing with these customers. They've actually completely resurrected these injection molding shops within their organizations. And the reasons that they're doing that are exactly what this slide is going to represent, right? So with your traditional injection molding, you're cutting metal molds, be it steel or aluminum. In some cases, you could do graphite. Regardless, you've got to outsource that generally to some sort of machine shop in order to make your molds. If you've got that internally, you're probably on the shorter end of that timeline, more the 2 weeks range. But if you've got to outsource that, especially given the current business climate and just state of transportation and all that right now, you're definitely looking at 6+ weeks in order to get your molds back. So the downside of that is, one, you just lost 6 weeks. Two, that was also quite expensive, and you don't get to check your part to see if you designed it right or if you needed to make a change or anything like that until you get your first shot off of that mold that you waited 6 weeks for. So a couple things could have happened in that time. One, the design could have changed completely. I mean, customer user requirements are kind of constantly evolving, and in order to stay on top of those things, you need to be agile, and you need to be able to respond to their needs quickly. The other thing is, you might have had, as I come from a design engineering background, as much as I have stared at parts, I have still messed up parts that have gone to a mold and they needed to go back and be remachined. So, there's always that possibility, right? Whereas if you take this additive, you can not only reduce the lead time for your molds significantly, I mean, down to days in some cases. You can also reduce the overall cost. So you can be more responsive. You can keep up with those user requirements. You can produce as well. You're still producing parts in the end thermoplastic, right? So it's not like you're 3D printing a part that you're trying to duplicate the properties of your end use plastic in. You're actually getting a part that's the component and the material that you designed around in the first place. So there's a huge benefit to this. You can use it for design verification. These molds, while they are fast, they don't last forever. So one good application here, you can check your tolerances, you can check your design, get a part quickly, and then even in some cases do a short run if you need a couple hundred parts or whatever. Run a couple of those parts off, build up your stock, and then outsource and get that steel mold made for when you want to shoot thousands, millions of components. Yeah, I think those are probably the big highlights for this application. It's something that we're pretty excited about, and with the customers that tested this out, I know they're pretty excited too to see these parts of their business, in some cases, like whole rooms and areas that were dedicated to this kind of come back to life. And they're really excited about getting these end components faster, and with the types of quality that they're getting off of them. They're pretty pumped.
I think that's great. Could you talk even a little bit tactically? This works with press fit kind of mold inserts, if you need to screw them in, just to give people a flavor for how, is this a drop-in replacement, for how I'm doing this today?
Yeah, exactly. So you're going to want to do this as a mold insert, right? So you need to check and make sure that your part will actually, fit in the mold space that we have printable. Next up thing is, injection molding machines come in all shapes and sizes. There are manual machines where you're literally, applying the injection pressure with your hand through a lever. In that case, you can modify your mold to work with that system. Generally, you won't have some sort of metal overmold or anything like that. It won't be treated as much like an insert. In some cases, you step up, you get a little more automation. You're going to have constraints around your mold design. So in those instances, what you're going to want to do is like a mold insert, basically, where you print the shape of the negative of the part that you want, and then you actually set it inside of a metal plate that's a component of your injection molding machine. And that can be done a couple different ways. We've had customers that actually just do, I guess it's not quite a slip fit, but basically line to line on the engineering drawing, create a tight tolerance fit where the pieces just kind of stay snugged up inside of those shells, those metal shells. And they've had really good luck with that. One pro of this material here is because it's a high impact resistant material, there's not a whole lot of brittleness to it. You can get a good fit, and if you have a misalignment on those two surfaces of your mold when they come together, you're not going to crack out your mold by giving it a squeeze. I think another option I have seen customers do is actually use screws to retain either retain the insert inside of the shell, the metal shell, or to even, you know, provide the clamping force to screw the two mold halves together. So there's a lot of options there. We've seen success in a lot of different ways of doing it. So it's adaptable to whatever machinery you may already have or are considering getting, I would say.
That's great. And you know, the cool thing is because this is such a high precision material, in addition to being a pretty tough, rigid one, is when we're doing these molds, we've not only had beta testers have success shooting engineering plastics like Delrin, but we've had jewelers have success replacing their metal molds with this as well and shooting wax in there. So it really, it serves a variety of industries with the same core pain point, which is that it's expensive and time consuming. And you have to have a high minimum order quantity that you're going to run through that if you're going the traditional mold route.
Correct. Yeah.
So I wanted to spend a little bit of time too, just helping people understand, where does this fit in our own resin portfolio? You know, how is it leveraging detail of one, flexibility of another to kind of arrive at this ABS-PC blend? Could you talk a little bit about, Eric, about where this fits in our whole portfolio of resins?
Yeah, absolutely. So we're highlighting these materials because externally, I mean, from this photo, they look very similar, right? But they all have very different use cases. So I was going to kind of go through here real quick and just kind of explain maybe best uses for each and where does the robust ABS-PC line up with all of this stuff. So I'm going to actually talk about the robust last. The next one in from the left is our resilient silicone product. So it's actually an elastomer. It's made to mimic the properties of a silicone. So short durometer of 70A. This is obviously good for any component that needs to kind of conform to a, you know, an odd surface, whether it's a sealing part or O-ring or anything that needs to conform to a more organic shape, maybe would be a better way to say that. There's good tear resistance on that. The major pro of it is the response rate. So typically with these additive elastomer materials, you'll get them to kind of bend and flex and deform, and they don't tear, they don't, you know, rip or anything like that, but they don't exactly come back to their original shape very fast. This material does. It's actually almost immediate. So that really makes that one stand out. The HD slate, the next one to the right, is actually a little more of a high precision / high detail resin. It's gray in color. It's got a really awesome finish on it as well. Actually, I would say the robust ABS-PC and the HD slate are kind of comparable in terms of the surface finish you get. It's this really nice matte texture. The HD slate, its big party trick is it's low to almost zero Z bleed. So if you need to make very small componentry and you're used to, you know, doing these parts on like a Swiss lathe or EDM process where you've got really, really tiny through holes or very, very small positive features that you need to turn out, this is the material for you. Next up is the Rugged Nylon 6. Rugged is a nylon-like material. So I would actually say that this is probably the most similar to the robust ABS-PC material. And what I mean by that is it's also a high impact resistant material. The main differences I'll highlight is that Rugged is more flexible. Definitely not an elastomer. It is still a rigid material, but you're going to get a lot more bend. The flexural modulus is a lot lower than robust ABS-PC, to the point where you'll almost see yielding or necking on these parts. You know, as you, in engineering terms, as you make them fail. High elongation on that material as well. But it can definitely, in terms of comparison with robust, it's actually even higher impact resistance than our robust ABS-PC material. Lastly, gray. Gray is, as its name would imply, a gray material. It is for generally prototyping purposes. Its mechanical properties are on par with most other acrylic-based 3D printing or liquid photopolymer materials. But it's, again, its big party trick is the fact that it can print big stuff really fast. So if you need to get your objects just in front of people, if you need to just hold them, make sure they fit in the hand well, get some sort of feel for, do I like the scale of this object? It's really actually easy to lose sense of, when you're working in CAD, scale. So it's a big benefit to actually hold a part in your hands. There's just something about that tactile feedback that you just can't replace virtually. So that material is fantastic for that. So Robust, I think, is a great complement to this product line. What it does is it kind of fulfills that high impact resistance hole that we have. Not really a hole. It complements the resilient and the rugged really nicely in terms of that. It gives more rigidity for folks that wanted different applications like snap fit and stuff that just needed to hold its shape a little bit better than the rugged could, especially in thinner walled applications. And the heat resistance of this material puts it at the top of our product portfolio as well. So that's kind of how that all lines up.
Yeah, I think that's great. This isn't by any means an exhaustive list of our resins. We have other design, biocompatible, and casting materials as well. But we were getting a lot of feedback where I love the detail of your HD slate. I love the impact resistance of your nylon 6, but I need something that's a bit more rigid in between. So this not only meets a nice engineering resin need with that ABS and polycarbonate blend, but to Eric's point, a nice sweet spot in our portfolio as well. I did want to touch briefly on just our full additive manufacturing workflow from our, call it support software, powered by B9 Crate 2.0. This fast technology is what enables us to have very high or very low effective resolution on all of our platforms, like our XL printer, which is about double the build area of our last largest printer, but it still gives you effective resolution under 25 microns. Due to that fast technology. And then Eric touched a little bit on our entire resin suite, and we complement that with automated post-processing from our cleaning unit to our curing unit as well. And whether you have our technology in-house, you're looking to bring our technology in-house, or you're just not quite ready to pull the trigger, we actually have a service bureau arm. So we have customers who use this. We're in the early prototyping stage. They're interested in new materials, but they're not quite ready to bring the technology in-house. They actually work with us on a kind of a consultative design review stage, all the way through a feasibility print to final part production. We also have customers who have our technology in-house, but when projects start to mount, or you want to take a vacation, or it's near year end, whatever it is, sometimes we can help with the overflow as well. So this is a great way to test the waters on an ABS PC or any other resin, in addition to bringing the technology in-house. I want to give us plenty of time for Q&A here before we wrap up. So please, if you guys have questions, go ahead and enter them into the chat at this time. And as we wrap up, I will let you know that we will send out this recorded webinar as well, with an option to pre-order the material. And you guys will get exclusive first rights to that. So we do have our first question. All of the sample images of ABS-PC show it black. Is it possible to get the resin uncolored? This might be a good opportunity, Eric, to talk a little bit about how our kind of B9X division works and what's commercially available versus tailored to customer needs. And that's from Ben.
Yeah, thanks for your question, Ben. The commercially available product will launch as a black only. Our B9X division that Danny touched on earlier is completely centered around customizing products that we're already making. If you have something that is very tangential to what we're already doing, this is an absolutely excellent idea that we should pursue together. So in these cases, if you need a material that's a slightly different color, if you need a machine that's gonna, operate slightly differently or what have you, just give us a call and let's talk this through. Is what I would say about that. If we can find a win-win for both of us, then we'll go for it.
Yes, and I know that's a request we get often, especially in the medical space, is can I get this white, clear, uncolored? So those are all requests we're used to fielding, and I'm happy to talk more with you, Ben. We'll reach out after this as well. I wanted to let you all know that with Cody here and Eric here, we're also available to do product demos, to help with sample requests as well for you to test out some of this material. Okay, and it looks like with that, I think that we have answered all of our open questions. So I appreciate everyone joining us today. Like I shared before, we will send out this recording to you all with first access, early access, to be able to pre-order this ABS PC and reach out at any time at that info@bnic.com if you have any other questions about the new material launches or any of the products you've seen today. So thank you, Eric, for, oh, hang on, I got one more. Delivery date, very soon. Think probably within the next month. I'm not gonna give you any more specifics on shipping until we line up with our technical team, but that's why we're opening up pre-order access this week, so that it'll be first in, first out, and whoever does those pre-orders will get that ahead of full commercial release. Well, thank you, Eric. Thank you, everyone, and we will talk soon.